Hi, this is Gurney Thompson. In this video, I'm going to be talking about some of the new stuff we've got for the hardware catalog for TruePlanning 2012. Up here, I've got two versions of TruePlanning running with the same project loaded in each. So here is the TruePlanning 2012 version, and here is TruePlanning 2010. One of the first things I wanted to go over was some of the cost differences you might see right out of the box when you load up some of your existing projects. So let's take a look. Right now I'm looking at TruePlanning 2010 SR1, and one of the first differences I wanted to discuss was a bug with the cost calculation for production tooling and test. I want to point out this bug only exists when you're using production spread manually over time. So you would be going to the number of production units input and using the spread dialog to specify a specific deployment or production array for when you're delivering production units. So in this case, in TruePlanning 2010, we're seeing a cost of $5 billion for production tooling and test. And in 2012, we're seeing a more realistic cost of $618 million. So that's one of the major cost differences you'll see, and it was just a bug that only exists when you're modeling production units over time. And that accounts for a significant amount of the cost differences you'll see between 2010 SR1 and 2012. Another difference I wanted to go over is the new maintenance activities. So in 2010, we had one activity that was called maintenance, and it's got a cost of $750 million. In TruePlanning 2012, we've split out that activity into 4 new activities that go into a more granular level. So we have unit level maintenance, intermediate maintenance, depot maintenance, and organizational maintenance. And the sum of these 4 new activities should add up to $750 million in this case, and looks like they do. So there shouldn't be any total cost difference there, but you will see it split out into 4 new activities. Another major difference you will see is the costs for the operation activity. This is 2010 SR1, and we have a cost of $380 million. And in 2012, we see a cost of $21 billion. This is because we've implemented a new algorithm for the cost calculation for the operation activity. And this new algorithm, we've gone over it at design reviews and run it by a lot of people. It makes a lot of sense. I've got a spreadsheet that goes over this new algorithm if anybody's interested. So just email me and ask for it, and I'd be glad to send it to you and explain why such a large difference in cost. It's a little too complicated to go over in this video to go through the algorithm, but just let me know, and I'd be happy to explain it. So the next thing I wanted to go over is some of the changes to the production over time capability in 2012. So I'm going to open up a new project for that. So I'm going to borrow from the design review slides, and just really quickly introduce you to to the production quantity over time. So this is a feature that allows the user to input specific information about when hardware will be produced and delivered. And there's a lot of advantages to that. It enhances budgeting with TruePlanning, and it allows for the calculation of learning loss due to gaps in production. What's new in TruePlanning 2012 with this feature? First, support for this feature was added to the assembly cost object, and I'll be going over this. I'll be showing this to you live. Second, there was cost calculation bugs fixed, which was the production tooling and test bug that I spoke about earlier. And third, there is improved feedback. So when you're setting the spread for the production units, setting how you plan to deliver them over time, that input implies a set of schedule dates. So if you also use the built-in TruePlanning feature to enter schedule dates, those inputs might contradict each other. And so the model, in the case of those kinds of contradictory inputs, it won't run and it'll alert the user on how to address that problem. So in order to model quantity over time, the first step you want to take is to enter start dates and only start dates for your production engineering, your production manufacturing, and your production tooling and test activity. And what the start date represents is the date that work begins on your first production lot. Dates should be entered for this activity on both the assembly cost objects and the hardware component or cost objects. So that would be step one. Step two is to enter the spread data on the number of production units input at the system cost object or the system folder. And in this spread dialog, year one will represent the 365 days following the start date that you entered in the previous step. So I'll go over that in a live example now. Here, let's take a look at the steps real quick. We've entered in a start date for the hardware component of 1/1/2012 at the assembly. At the hardware component. The same start dates on the assembly. And so that was step one. And step two is to enter your manual spread for the number of production units at the system cost object. So here we have a spread of 100 in year one, a production break, 100 in year 3, a production break, and 100 in year 5. When we look at the costs as they occur over time, we see a cost distribution that matches that sort of spread array. So here's your first production lot where you build 100, a break, lots of learning occurs, and you start back where you initially began. For your second lot, and so on. If I then look at the assembly level, here we're looking at the red lines representing your hardware component costs and your blue lines down here representing your assembly costs. And so in 2012 now, the assembly costs will match up nicely with your hardware component, and your assembly will match up nicely. One more thing I wanted to discuss with production over time is the production gap learning loss factor. So when you're modeling production gaps, during a production gap, a project will experience a loss of learning, and essentially it would be moving back up the learning curve. And there's an input that now works with the assembly as well, and it's called the production gap learning loss factor. It controls the rate at which learning loss occurs, and it's found on the global input sheet at the system folder. So here is that input, and a value of 1 means that you will experience loss of learning at the same rate at which you experience learning. So the amount that you've learned over 1 year of producing units, you will unlearn that same amount over a year-long production gap. If I set it to 0.5, I will only unlearn half of what I learned during the first year. So by setting this to 0.5 and looking at the costs, you'll see here is about the halfway point of your learning curve for the first lot, and that's exactly where you start your second lot, with about half the amount of learning that you had from the first lot. And that trend continues over into your third lot and so on. And you'll see the same kind of effect at the assembly level. So that's the basics of how production over time works in 2012. Again, feel free to ask me any questions or send me an email if you need any further help with that. I went over it in more detail at a design review, and I can go over it again if people would like. So moving on, I wanted to talk about some other new things in TruePlanning 2012. Another one is a new input we've added. It's called Prototype Support Adjustment Factor. And some of you might be familiar with this. It was called ProSup in PriceH. And it's a parameter used to adjust development engineering and development manufacturing costs when design or fabrication yield problems are anticipated. In the notes on the input, it goes over the exact, the nature of the cost changes when you use the ProSup, or the Prototype Support Adjustment Factor input. It is slightly different from how the PES version of ProSup was implemented. So please check it out and give me any feedback that you might have on if that's the correct way that it should be working, or if you find any problems. And finally, there's one more thing I wanted to go over, which is part of the HL, one of the HL inputs called units permitted to be out of service. In previous versions of TruePlanning, this input was here, but setting its value to trying to use this input, I guess was buggy in a way, and I think it would set all your costs to 0 whenever you tried to use it. So that input and its effects have been fixed in TruePlanning 2012. And the same with the control of structural modules input. Previously, it didn't work in earlier versions of the software, but in TruePlanning 2012 fixed. So I urge people to take a look at those inputs and make sure they're working as you would expect them to. These two inputs should now work very similarly to how they worked in PriceH. So those are some of the main new features that you're going to see in the hardware catalog for TruePlanning 2012. And thanks for listening.